Hello there. Welcome to a discussion about relational database normalization. My name is Lisa Fears, and we're going to be talking about normalization in the seven normal forms as it relates to relational databases. Are you ready? Here we go. So what is database normalization, and why are we talking about it? Well, a normalization refers to, as you can see on this slide, is a process or a set of rules for removing any unneeded data from your database. It creates storage efficiencies, data integrity, scalability. Typically, in a properly normalized database, some of the following characteristics are in play. There is an absence of redundancy, minimal use of null values, which null values just takes up space in your database, and also a minimal loss of information. In relational database models, quantifying or labeling, measuring, if you will, how efficient a database is called normal forms. Typically, normalization involves splitting existing tables from within a database into multiple ones, which then can be rejoined or linked each time a query is asked or issued, each time a question is asked of the data. So where did the concept of normalization come from? Well, here's just a little bit of history. The man you see on the screen, Edgar F. Codd, first proposed the process of normalization in 1971. He had written a paper and was presenting this paper in which he talked about the process that we would eventually know as first normal form, and his paper was called A Relational Model of Data for Large Shared Data Banks. And in his paper he said, and I quote, "There is, in fact, a very simple elimination procedure which we shall call normalization. Through decomposition, non-simple domains are replaced by domains whose elements are atomic or non-decomposable values." Atomic, in this sense, means the smallest unit, or can't be divided anymore. And so 1971 was the first time that we thought about normalization as a concept and how to do it. In 1974, Edgar F. Codd and a gentleman named Raymond Boyce joined forces and presented a normal form called the BCNF model. And that is considered the normal form 3.5. Edgar Codd originally established 3 normal forms, 1NF, first normal form, 2NF, second normal form, and 3NF. And then again in 1974, a 3.5 normal form was presented called the BCNF. Okay, so typically when we're talking about database optimization or database efficiency, generally in the design of databases in the scheme, those databases that are efficiency or normalized to the third normal form is generally thought to be good enough. Most databases are in the third normal form, first, second, or third, and often the 3.5. And again, the BCNF was put into play in 1974, really just to deal with certain types of anomalies that the third normal form couldn't really deal with in those rules. But beyond the BCNF, there are 3 other types of normalization: fourth normal form, fifth normal form, and then a 6th one, 7 if you're counting, which is called the domain key normal form. 4, 5, and 6 are not typically used just because of the amount of resources, the time, and the expense that it takes to optimize or to normalize a database to those 4, 5, and 6. Again, Generally, databases in use today are scaled and are efficient in the third normal form. Okay, so how do we define first normal form, second normal form, and third normal form? And those, again, are the most common normal forms. First, in first normal form, 1 NF, all data values are atomic. Atomic, again, means that the data is separated into the smallest available category or cannot be divided anymore. And so first normal form means that data is individual and is in its smallest category. Second normal form, oh, and incidentally, first normal form deals mostly, or actually exclusively, with rows of information. Second normal form is first normal form plus a no non-key attribute that is partially dependent on a candidate key. That's a whole lot of stuff to say that second normal form generally deals with columns of information rather than rows of information. Again, it is to deal with non-redundant data, efficiency in the data, no cells or fields that are empty or with null values, and has to do with not having or having no key attributes that is partially dependent on any candidate keys. Okay. Now, the normal forms are progressive, meaning that a database cannot be in second normal form unless it is already in first normal form. So these are progressive rules that build on one another, progressive processes, starting with first normal form to third. Third normal form is, again, in progressive order, a second normal form table or database plus the fact that no non-key attributes depend transitively on a candidate key. What does that mean? Well, generally, what that means is that there are no indirect relationships amongst the columns. So therefore, A doesn't necessarily depend on C, column C, even if A depends on B and B depends on C. And so it has to do with transitivity on the candidate keys. So in third normal form, the database must relook. Here's an example of a table that I want to show you that is not normalized right now. This is we're just going to call this table number 1, and table number 1 is a non-normalized table at this point. And you could see that there are some problems with this table, and the reason that it's considered non-normalized is, well, first, the table is not very efficient with storage. So for instance, you can see that there are multiple authors' names or columns with authors. So there's an author number 1 and author number 2. And in the subject field, see here, there are actually tables with multiple values in the field. So it does not protect data integrity, and it's not going to scale well. If we try to look something up with this table in this form, it's going to be very difficult to find the subject, given that there are multiple values in those fields. So here's one way that we could normalize this table. We could normalize it this way, but technically it's still not the best design. Why? Well, because there are still 2 rows for a single book. So if you look, there are 2 rows for a single book, right? And this is ultimately a violation of the second normal form. A better solution to this problem, or to fix this and to normalize this to first normal form, would be to separate the data into separate tables. And the subject table then would be removed from it. And so with the amount of data that you saw in table number 1, we could actually, or should actually, create 3 separate tables and then create relationships between those three tables. So in this slide, you see what the three separate tables are. We would have a subject table, an author table, and a book table. Okay? How does this create efficiencies? Well, you can see that there isn't any data that is repeated, so there's no redundant data, and the kinds of ways in which we join this information together has to do with building relationships between them. Each of the tables has a primary key, in this case, the ISBN number. So in the book author table, again, data taken from our original table 1, each of the tables has a primary key or a unique identifier that is listed in the table. And so because there is a primary key or a primary set of information or data, it's used to join these two tables together when we're asking questions of the data or querying the data. In a relational database, the primary key is also used as an index, which speeds up the data retrieval based on the actual information contained in the primary key. So in this example, first normal form, the tables have these relationships between them, right? So they're connected by the primary key, their unique identifiers. Okay, so then what does it mean then if we're in first normal form and we want to move it to second normal form? We have some business reasons, some economic reasons, data integrity for data integrity purposes, or the need to scale our database. We want to move this to the second normal form, or 2FN. Well, again, it must be in first normal form first, and then to move it to second normal form, then the second normal form deals with the redundancy of data in the vertical columns. So again, first normal form deals with redundancy across horizontal rows. Second normal form deals with redundancy in a vertical fashion. So take a look at this second normal form table. If we look at these relationships, we can see that there is a one-to-many relationship present in these two tables in second normal form. And second normal form then relies on a primary key, like the primary key, the one relationship, publisher ID. So in this example, there's only one publisher, but this publisher may publish several books, right? And that's real life. And so in this table, there's a primary key, publisher ID, and in the second table, there is a publisher ID field. This is also a unique identifier, but it is not the primary key. It is not the primary key. This is considered a foreign key. These two create a relationship, and this is a one-to-many relationship. So in second normal form, again, dealing with redundancy in data in the columns, eliminating that redundancy by creating smaller tables chunked out for manipulation and developing of relationships. Then moving on to third normal form. Third normal form has to, again, in a progressive fashion, has to be both first and second normal form, dealing with the redundancy in data in the vertical and the horizontal, but also requires, or the rule is, that there's no functional dependencies of non-key attributes on something other than the candidate keys. So that would be the primary key, forward key, composite key. And a table in third normal form, if all of the non-primary key attributes are mutually independent. So let me say that again. A table in third normal form, it is in third normal form if all of the non-primary key attributes are independent. And then again, there should be not any transitive dependencies, meaning one is more dependent on the other, or on that. The BCNF form 3.5, it was just established, again, to deal with some data anomalies that weren't covered in the third normal form, 3NF, and it requires that it first progressively be in third normal form, 3NF, and only the determinants are the candidate keys. Okay? Fourth normal form deals with, and again, this is fourth, fifth, and sixth normal form are not typical normalization tactics that are followed or rules that are followed. These are more rare than the third normal form. But in order for a table to be in fourth normal form, there must be the elimination of all of independent many-to-one relationships between the columns. So no independent many-to-one relationships between the columns. And it again must first be in the BCNF form, the Boyce Codd normal form, and the relationship or the relation cannot contain more than one multi-valued attribute. Fourth normal form. Fifth normal form follows. It again has to be in fourth normal form. It has to be satisfied, and then for fourth normal form, and then to be fifth normal form, all the tables are broken into as many tables as possible in order to avoid redundancy. Once it's in fifth normal form, it cannot be broken into smaller relations without changing the facts or the meaning of the original tables within the database. So it is broken down in the smallest, most atomic form. It cannot be broken down in any smaller relationships without changing the facts or the meaning of the table. And then finally, the domain key normal form, DKNF, is the relationship or the relation where there's no possibility of insertion or deletion anomalies within the database. So it is so locked down and so restrictive, and the rules are in such play that there is no way that the insertion or deletions can occur from within the database. Well, that's a summary of normalization. What is it again? Well, it's the rules for removing redundant data from your tables. And this concept of normalization is very important to consider when designing a database. Database design relies on efficiency, the design relies on data integrity, and even more so now than in 1971 when Codd first introduced the notion of normalization, must be scalable. The information that's housed in databases now is exponentially larger than it was in 1971. Again, a properly normalized database must have the following characteristics: the absence of redundancy, no repeat data, the use of or the minimal use of null values, and the minimal or no loss of information as processes are run. Again, in relational database models, quantifying how efficient database is called a normal form, or NF. There are generally 6 normal forms, seven if you consider the 3.5 normal form, and third normal form is widely accepted as the sufficient design. Any questions? Well, clearly you can't ask me questions now, but in the future, as you consider normalization, if you do have follow-up questions, you're welcome to at lisafearsplans.com. Thank you for your attention. I look forward to hearing from you. Bye-bye.